Alright, so what we're looking at today is an introduction to the unit circle, okay? So you can ignore pre-cal honors here. Initially you could just watch, alright? I'm going to provide this as a PDF to you later and you can see the video too if you want. But really the key here is that you need to see the patterns, okay? So stay with me here. If you see the patterns, this is a piece of cake. Alright? If you don't see the patterns, then it's going to be more of a struggle. Alright? So the more you're engaged and paying attention, the easier this is going to be. So, first of all, just defining what we're talking about when we're talking about a unit circle. It's a circle where the center is on the origin, and it has a radius of 1 unit. So that's why we call it the unit circle. Okay?
Wait, radius is
from the origin to the edge of the circle. It's always going to be 1.
Is it like inches, centimeters?
Doesn't matter.
Wait, the radius is 1?
The radius is 1.
So wouldn't the circumference always be the same too?
Well, circumference is 2 pi r, right?
Yeah.
So 2 pi times 1 would just be 2 pi. Or 6.28.
So, I think.
Okay.
So figure out like a triangle within it.
So, yeah, let's look at this, because what we're going to be looking at specifically today is these angles. Now, you guys learned about an angle in standard position. I don't know if you called it that, but where you're starting at the positive x-axis and you're rotating this way. You guys looked at that? I saw it on some of your stuff from earlier. Okay? We're talking about an angle where this is 0 degrees. The positive x-axis would be 0 degrees. And we're rotating counterclockwise. Okay?
Yeah.
So this up here would be 90 degrees. Over here would be 180 degrees. If we keep rotating, that would be 270 degrees. And once we come around to the full circle, that would be 360 degrees. Okay? So that's the start of what we're looking at here with our unit circle. That angle is how we're going to get the x-coordinate and the y-coordinate of a point on the circle. Okay? We're looking for a point on this circle. Let's get rid of some of this here. All right. So we have this point xy. What we're going to develop today is a number of different angles, the angles that you need to know on the unit circle. And then also we're going to develop how to find the points on the unit circle. Okay? So that's where we're headed today. So let's start out with the angles, okay? The angles in the unit circle come from dividing the circle 2 different ways. Okay? We already said that we have 0, 90, 270, and 180. Or 0, 90, 180, and 270. Okay? So that's the beginning. But you'll notice here, in this circle with the blue lines in it, we divided it, instead of just in quarters, we divided it into eighths. Okay? So you'll notice we took each of these right angles that we had, and we cut them in half. Alright? So what's half of 90?
30. No.
45.
45. That's alright.
How are you gonna help?
Okay.
Yeah, I don't know. I was trying to go off of what Jeremy was trying to teach me instead of all.
Alright. The 30s, we'll get down there.
My eyes are really sensitive with this thing.
That's okay. Alright, so that's 45. So basically, when we've divided it here, each segment is going to be another 45 degrees. So we go up 0, 45, 90, 90 plus another 45 is 135, then 180, plus another 45, we're up to 215. Another 45 gets us up to 270. Another 45 gets us up to 315. And then finally we end up at 360 degrees. Does that make sense so far?
Yeah, I just don't understand what we're trying, like.
Yeah,
I don't think we've gotten
225.
there yet, but what are we eventually
Thank
doing
you.
with the circle?
Okay? We'll get there.
Okay.
You'll understand once we get there. Basically, the idea is you're going to be able to find know off the top of your head the sine, cosine, and tangent of all of these angles. Once you know the unit circle, you'll know without having to use a calculator what the sine, cosine, and tangent of all these angles is.
Is it because they're all the same size triangle?
You'll see. We're going to actually get to that. Okay? So now you'll notice the one on the red that's divided up there. There we divided each right angle into thirds. Okay? So each third is going to be how much?
360 divided by 12. Oh wait, is there 12 or is there 9? Like 9.
No, it'd be 12.
30 degrees.
Yeah, each one is 30 degrees. So again, we still have this 0, 90, 180, 270. But now we're dividing it into segments that are 30 degrees.
Wait, is the angle that's like in the middle, is that what is 30 degrees?
This angle right here, all of these angles have one side there on the x-axis, and they rotate up to 30 degrees.
Oh, so
Okay.
where the x-axis and like the 90-degree line go through in the middle?
They always start here. They always start at 0. And they're going to rotate so many degrees counterclockwise. Okay? Now, let's go around here. The next one is going to be how many degrees? 60. Then we have 90, then
120.
good. Then
150.
good. Then 180, then
210.
210.
240.
Good.
310.
270, then we got to
Oh wait, that's 300.
300,
And 330.
and that's 360 again. Okay? So what happens here is we've divided our triangle into, we've divided each quadrant in half, and then we've also divided each quadrant into thirds. And what we end up with is when we put it together, I'll just show you the first quadrant here. We end up with 0 degrees, this is our 30, then 45, then 60, and then, of course, this is 90 degrees. Okay, that's just the first quadrant. Okay?
I think I'm following.
Alright. So that's not too bad.
Definitely gonna get worse.
No, come on. Alright, so from here, we've answered the question of what the angles are. The next thing that we need to look at is what are the values of the sides, okay? Now, have you guys done 45, 45, 90 right triangles and 30, 60, 90 right triangles this year?
We've just done right triangles. Nothing like
You did
specific.
SOHCAHTOA.
Yeah.
Okay.
To find the angles.
In geometry, you may have looked at the special right triangles, 45,
Yeah,
45,
we-
90, 30, 60, 90, but it's been a while, okay? So there are patterns to these. That's why they're called special right triangles. They're patterns. We'll go with the SOHCAHTOA route because that's something you're more familiar with. But I want to look at the actual triangles that we could draw if, say, for the 30-degree angle, we drop this line straight down to here. Okay? And the reason why I'm drawing that triangle is because the length of this side will be the x-coordinate of this point.
It's probably gonna be less than 1, right?
Okay? It will be less than 1. In fact, all of these values will be less than or equal to 1. Okay? And then this side of the triangle right here will tell me what?
The other, the hypotenuse. Like you can
The
use
y.
that to figure
No?
out.
It's going to be the y. It's going to be the y. What's the hypotenuse?
The little line going from where the 30 is to the middle.
Yes. How long is that though?
Oh, 1.
It's 1. We have a unit circle, right? So the hypotenuse here is 1. Okay? So let's use some right triangle trig here with SOHCAHTOA. And you'll see here, I'm telling you that this side here is going to be a half, and this side here is root 3 over 2. Okay? You say, well, how are we getting that? Okay? Well, let's look at figuring out, say, the x coordinate first. If I were doing the x coordinate, I would have sine of 30, I would have cosine of 30 is x divided by 1. Okay? That's x divided by 1, which of course is just x. If you were to use your calculator and punch in cosine of 30, what do you get?
0.866.
Yeah, 0.866. Well, guess what 0.866 equals? Square root of 3 divided by 2. Okay?
Wait, how did... No, I was following you.
It's okay. Alright? We get the actual square root of 3 over 2 back here with the special right triangles. And since you haven't worked with these for a long time, that's why maybe a little hard to see. See your 30 here? The adjacent side is always going to be something times radical 3. And the hypotenuse is always going to be 2 times whatever that value was, x. Okay? So if I do the cosine, it's x root 3 x root 3 over the 2x, the hypotenuse, right? Well, the x's can cancel out. So the x's cancel out, and I'm left with just a root 3 divided by 2. Okay? So cosine of 30 is this over this, adjacent over hypotenuse. Cosine of 30, if the x's cancel out, it will always equal root 3 over 2. Okay? Now, what will sine of 30 equal? Using the same strategy there.
Oh, this isn't my calculator. I don't know how it works.
Would it be x over 2x?
Okay. Think in terms of SOHCAHTOA. Sine of 30 is the opposite x
Over 2x.
over the hypotenuse again, 2x. The x's cancel, and you get a half. Okay? So the sine of 30 is a half.
Is it always going to be that?
Yes. Okay? Now watch this. At 30 degrees, no you won't, you'll get the hang of it. Okay? At 30 degrees, we have this point here, and we just saw that on the unit circle, with a hypotenuse of 1, you'll notice here, cosine of 30 is x over 1. So the x coordinate is the cosine. Alright? The x coordinate is the cosine. So when I'm writing this point here, actually, can I erase that? Nope, not yet. When I'm writing the coordinates of the point here, for 30 degrees, the x coordinate is the cosine, that's root 3 over 2. Okay?
And then is y just 1/2?
The y, yeah, because look, sine sine of 30 is 1/2 over 1, okay? That's the y coordinate, all right? All right, so we now have the point root 3 over 2, 1/2. Okay? So there are 5 points here just in this first quadrant. There's 5 points. We already know 1, 0, and 0, 1. Those are easy. Now we figured out root 3 over 2 and 1/2. Okay? So let's skip 45 for a second, and I want to look at the 60. If this right here is a 60-degree angle, what's this angle up here?
We're
30. So guess what? Isn't this triangle the same as the triangle we were just working with?
Yeah.
Yeah, but how is it going to be different?
The x and y would be switched.
That's right. All we did here is we took this triangle and we flipped it like this.
Yeah.
Okay? So instead of x being root 3 over 2 and y being 1/2, now x is 1/2, y is root 3 over 2. Okay? Make sense?
Yes.
Okay?
I remember doing
All right.
I had an A minus before.
So-
maybe last year.
So once we do the 30, 60, 90 right triangle, we figure out sine and cosine, we get those two sets of coordinates. We use the 45, 45, 90 here with cosine, and we get the x coordinate, and we see that, hey, this is in isosceles triangle, the two legs are the same, so the y coordinate also has to be root 2 over 2. Okay? Now, we saw down here that with the 30-degree angle, sine ended up just equaling the y coordinate, and cosine ended up just equaling the x coordinate. And that's the beauty of the unit circle. That's consistent for all of the angles. The cosine is your x coordinate, the sine is the y coordinate, and even beyond that, notice here, what's tangent of 30 on that triangle there? Tangent of 30 degrees. What's the opposite side? Because tangent's opposite over adjacent. Opposite is 1/2 over, yeah. Opposite over adjacent. Now, rather than simplifying this, check this out. 1/2, we already said, is the sine of 30. And root 3 over 2 is cosine of 30. So actually, we can not only use the unit circle to help us know what sine and cosine are, if we divide the sine by the cosine, that tells us what tangent is too. Okay? So just to kind of sum up, the y coordinate is your sine, the x coordinate is the cosine, and the tangent is going to be the sine divided by the cosine, which is y divided by x. Okay? Hate it when it puts these little things in there. Okay. So that's kind of the summary of where these points come from. Alright? Notice we've only done the first quadrant, but we've done the hard part. Okay?
Wait, so you just recorded that whole thing?
Yes.
And it has voice too?
So here's our unit circle, blank. And I want to show you what we've learned so far, just to kind of help you see how far we've come so far just in this period. We've already gotten all of the angles. 0, and let's see if you guys can give them to me. 30,
45, 60, the same thing, increments of
30,
So 120,
15,
2150,
135.
150.
135, and then 150. Notice, remember we put the 45s and the 30s together into one thing. Because we cut it into quarters and we cut it into thirds. So we're putting it together all in one. So now this is 180. This next one is
220. No, 210.
210. Then
225.
225.
240. 270. 300. 300.
Yeah, you're right. 300.
315. 330.
Yep.
And then that one is common sense.
And 360. Okay. So you already know all the angles. This isn't that hard, right? You already know all the angles. Okay. The next thing is the points. Well, just because this is the unit circle, we already know 4 of the points. That's 1, 0, 0, 1, negative 1, 0, and 0, negative 1.
Is it negative because it's on the other side of the x-axis?
Mm-hmm.
And another one's negative 1 because it's
And then we also just figured this out. Root 3 over 2, 1/2. Root 2 over 2, root 2 over 2. And then 1/2 root 3 over 2. Okay? So already we've done all of that. The cool part is the other 3 quadrants here are just reflections of what we've already found.
So like 120 would be radical 3 over 2 comma 1/2?
No. If we move this over here, we're staying at the same vertical level, right? So the y is going to stay the same, right? Root 3 over 2. But how would we get the same distance here over onto this side? If this is 1/2, this has to be a distance of 1/2. So what would the coordinate be?
x radical 2? I don't know.
Don't overthink it, huh?
2 over 1?
Not a bad thought, but not quite. We're just going the opposite direction, right?
Negative.
Negative. Negative 1/2 root 3 over 2. You see that?
I don't like this.
And you can do that with all of them. Okay? Instead of root 2 over 2, root 2 over 2, over here, it's negative root 2 over 2, root 2 over 2. Instead of for 30, where it's root 3 over 2, 1/2, over at 150, it's a negative root 3 over 2, 1/2. Okay?
I think I'll get it better.
But how would this like vary on a test? Like,
It won't. That's the beauty of the unit circle. It's always the same.
So,
memorize that.
Once you
people
know
can
it,
memorize this and just go to the test and just.
yes,
Oh.
absolutely.
So I can literally just
I'm
memorize
taking a
that.
picture of this right here.
I can
Exactly.
just memorize that.
Yes. Now, we have to do the bottom half.
I have a photographic memory. I think it's simple.
Well, good. You should be a piece of cake for you then. All right?
Plus,
So,
so easy.
we have to do the bottom half. All right? Just looking at the 30-degree angle here. Notice if I brought this straight down here, what's going to change?
In the
Negative 1.
box, right?
It's going to be negative 1/2. So it's root 3 over 2, negative 1/2. And the same thing is going to be true for the other 2 points down there.
Oh, my question is what would happen for the like the other side?
Well, what do you think? Here,
Would it be like
to go from here straight down,
negative 1/2 maybe? And positive root 3 over 2?
well, it's still a negative root 3 over 2, but now it's also a negative 1/2. Notice both of them are negative there. Okay?
a
We'll fill in the rest of this tomorrow. All right. Have a good day, guys.